We will see one problem from tutorial 4, problem number 4.5. So determine the total charge. So the first part of the question is part A. That means there is a line which carry charge. So it is like this. So this is x-axis, y-axis and z-axis, and there is a line which carries charge. Its length is 5 meters, so it's starting from x is equal to 0 and ending at x is equal to 5. Okay, and the length is in meters. Okay, meters. Now the line charge density is given. The line charge density is given, rho L is equal to 12x square millicoulomb per meter. You want to find what is the total charge. So total charge is given as, you have to integrate, okay, because this is a small line, so the charge which is along a small part x, for example, let us consider a small piece dx. So charge dq, the charge dq is given as the line charge density multiplied with dx, or it is nothing but 12x square into dx, because the line is placed along dx. That's why we are using dx now. So total charge q is given as integral dq, okay, over x changes from 0 to 5, or we can say in general over the line, okay, over the line. So this is nothing but integral 12x square dx, where x changes from 0 to 5. Okay, so since we are multiplying with the dx, you can see what will be the unit here. The unit now, it will be millicoulomb, okay, because dx is having the unit meter. Now this much millicoulomb, so this is equal to, q is equal to 12 into x power 3 by 3, because integral of x square is x power 3 by 3, 0 to 5. So this is equal to 12 into x power, this means 5 power 3, okay, this much millicoulomb. So you will get this answer as 500 millicoulomb, which is equal to 0.5 coulombs. So this is the total charge on that line. Okay, so I think this is clear to you. So the next part of the problem is on the cylinder. On the cylinder, rho is equal to 3. So the second part of the problem, it is like there is a cylinder, and this is x-axis, this is y-axis and z-axis. So there is a cylinder, and what is the property of the cylinder? The cylinder is placed, actually the z-axis, the z of the cylinder, the height of the cylinder is changing from 0 to 4. So it is changing from 0 to 4. So it is placed here. Let's say it is placed here. Okay, then it is having the height, okay, the height like this, okay, the height of the cylinder, z is changing from z equal to 0 to z equal to 4. So this is the height of the cylinder. Now the charge density on the surface of the cylinder is given. The charge density on the surface of the cylinder is given. What is the charge density? It is rho into z square. It is rho into z square. Okay, and what is rho? Rho is the radius of this. Okay, rho into z square. So what will be the total charge? What will be the charge dq if you are taking a small surface area? If you are taking a small area ds, let's say you are taking a small area ds, dq is equal to rho s into ds. But here you want to represent this in terms of, you can see this is a cylindrical structure, so we will not be using the Cartesian coordinate to represent this. So better we can use the cylindrical coordinates itself. So let us consider some angle from the origin. Let's say this is phi. Okay, let me use a different color for this. Okay, I will use, this is phi, and the radius, you know, it is given, and at height actually this is your z. Okay, so in terms of phi, in terms of rho, phi and z, we can write ds as rho into d phi into dz. So the reason for this we have already explained in the previous videos. Okay, so we will get this as rho s into rho into d phi into dz. Okay, so to find the total charge q, which is equal to integral dq, okay, over the whole surface, that means we will be considering only the surface, outer surface here, okay, of the cylinder, because you see here that the charge density is given as a function of z. So along z axis it is changing. So now we will see here we have the integration of rho s, okay, into ds. And what is our ds now? The ds is given as rho into d phi into ds. And also you know that the phi is changing from 0 to 2 pi, because we have to a cylinder, if you take the bottom part of the cylinder, you can see it's a complete circle. So phi is changing from 0 to 2 phi, and the remaining is remaining part is z is changing from 0 to 4 as given in the question. So you will get it as integral z changes from 0 to 4 and phi changes from 0 to 2 pi. Okay, then we will get what is our rho s. The rho s is given as rho into z square. Then again there is a rho, a term for rho is there, then d phi dz. So I will use the next page for explanation. So my charge is equal to integral z changes from 0 to 4 and phi changes from 0 to 2 pi. Okay, next is like you have rho here and another rho here, so rho square into z square. So it's become rho square into z square into d phi dz. So this become, I will first integrate over phi. So 0 to 4 rho square. What is rho? It is given like rho is equal to 3. Okay, it is given in the question. You see, it is given in the question rho is equal to 3. So rho square will be equal to 3 square, which is equal to 9. Okay, so please note this. So this become 9 times what is the then it is z square. What is the integral of phi? Integral of d phi is phi, and phi changes from 0 to 2 pi. Okay, then we have dz is z. Okay, dz. Okay, dz. Now we will get q is equal to integral 0 to z changes from 0 to 4 9 into z square into, if I give the limit for the phi, this become 2 pi minus 0 into dz. Okay, so you will get it as 2 pi into 9 integral z changes from 0 to 4 z square dz. So q is equal to 2 pi into 9, then integral of z square is z cube by 3, then z changes from 0 to 4. Okay, so this become 2 pi into 9 into z cube is like 4 cube. Okay, so 4 cube divided by 3. Now be very careful while doing the problem. You see here that the unit is nanocoulomb. Okay, it is nanocoulomb per meter square. So our charge will be of the order of nanocoulomb actually. So you can see here that my charge will be like, here I am going to substitute, right? Yes, my charge will be in the nanocoulomb. Okay, my charge will be in nanocoulomb. So my charge will be in nanocoulomb. So everywhere I have to add this nanocoulomb here, nanocoulomb, and this also nanocoulomb. So this is also nanocoulomb, nanocoulomb, and here also this much nanocoulomb. So you will get this answer as 2 pi, okay, into, you see here this is 9 over 3, this become 3 into 4 cube. So 4 square is 16, so 16 into 3, this much nanocoulomb. So you can multiply and get the answer. I think the answer is coming to be 1.206 microcoulomb. This final answer is written in terms of microcoulomb. Okay, I hope it is clear to you. Thank you.